Hi, in this tutorial we are going to solve a question related to chlorination of alkanes. The question asks us, draw all constitutional isomers formed by monochlorination of each alkane with Cl2 and H mu. So if you understand the question, the question asks us monochlorination of alkane in the presence of light. And this is a radical mechanism. So the reaction should chlorinate the different positions of alkanes. Let's start. The first case, I'm going to solve only option C because these are all alkanes and pretty much the same concept. So you have to find different types of hydrogens on the molecule and you have to chlorinate that position. So let's write the general reaction. So alkane and chlorine in the presence of UV light, we are going to chlorinate different positions. So let's find how many different hydrogens are on the molecule actually. So definitely this carbon has 3 hydrogens and this is the first type of hydrogens. It's a primary carbon, and we have here a tertiary carbon having only 1 hydrogen here. We have here at the third position, since it's a symmetric molecule, both number 3s are same positions. So we have, these are secondary carbons, so we have 2 hydrogen on both positions. They can be chlorinated potentially. And the last one we have here, the fourth type of hydrogens. Those are again secondary hydrogens. So these positions can be chlorinated. So if we chlorinate, what kind of products we are going to get? So let's start from the first position. Let's just replace a hydrogen with a chlorine molecule. So this is the first monochlorination product. And if we chlorinate the second position, just if we grab 1 hydrogen, then if we place there a chlorine, so this will be a second product. And the third product will be at the third positions. So I'm going to just draw 1 because if you place another chlorine at the other position, it will be the same molecule basically. And the last one, if we chlorinate one of the fourth positions, I'm going to just show 1 position here. Okay, this is the answer. If we add a second part to this question, how the reaction works, what is the reaction mechanism? And we say that this is a chlorination in the presence of light, so it has to be a radical mechanism, right? In the radical mechanisms, we generally have 3 steps. In the first step, we called initiation step. What happens in this step? The chlorine molecule will dissociate into 2 chlorine radicals in the presence of UV light. So let's just draw this reaction mechanism. So this is the chlorine molecule, and in the presence of UV light, the sigma bond will break evenly into 2 equal radical fragments. So this is the first step. And in the second step, we call this is a propagation step. So what happens? The alkane, let's draw the alkane. And I'm going to explicitly show the hydrogens here so that you can follow up the reaction mechanism. So the alkane is going to react with the radical, so the radical will abstract one of the hydrogen. So how the reaction will work? Basically, the radical unpaired electron will combine with one of the electrons of the sigma bond between carbon and hydrogen, and it means that hydrogen and chlorine will combine into a single molecule, and the other electron on the bond will stay on the carbon as an unpaired electron. So we are creating here an alkane radical plus HCl. Okay, then what can happen as a different propagation step? The alkane radical, let me draw it here. The alkane radical can react with another chlorine molecule, because in general, the first initiation step, we do not consume all the chlorine molecule, so we have still some chlorine molecules around. So the alkane radical can react with another chlorine molecule. And how? So basically, again, very similar to the other propagation step. The unpaired electron from the alkane is going to react with one of the electron on the sigma bond between chlorine and chlorine. So basically, alkane and chlorine combining, and the other electron on the sigma bond between chlorine and chlorine will stay with the other chlorine species. So what we are ending up with the desired chlorination product. Let's show the lone pairs, plus another chlorine radical. So basically, in the propagation step, we produce more radicals. In the initiation step, that's the first part of the reaction. It initiates the reaction by producing initial radicals. But in the propagation step, we create more radical species. Okay, so there is also a third step in the radical reactions, which we call it termination reaction, termination step. In the termination step, generally two radical species can combine into a non-radicalic species. For example, the first one can be if you have two chlorine radicals reacting, so the unpaired electron coming together forming sigma bond. So this is one possible termination step that terminate reaction, stop the reaction. That's, let's say, A. Another possible reaction is actually like the product formation. So if you have around the alkane radical and if you have chlorine radical, they can combine and they can form a sigma bond, and this is the actually desired chlorination product. In a third type of termination step, two alkane radicals can react with each other and it can terminate also the reaction. I'm showing this way. Again, like these two unpaired electrons can combine together to form the sigma bond. So we can form another alkane. This I'm drawing this way. Okay, these are like potential termination steps. But the important step in the propagation step, the formation of the product, and also in the termination step, the formation of the desired chlorination product. I think we forgot to add chlorine here, and lone pairs. Thank you so much for watching the video.